All right, we'll go ahead and get started. My name is Scott Wheeler. I'm a support engineer here at CircleCI, and today we'll be going over the CircleCI advanced features in today's office hours presentation. There's a chat available. Please enter any questions there. I'm joined by Jonathan Cavazos, who will be answering questions you have, and we will also have ample time for a Q&A at the end. Today's agenda is how to find answers and ask for help, the different execution environments we offer, machine, Windows, Mac OS, and Docker, how to use workflows, secret management, test results and artifacts, how to speed up your builds, the CircleCI API, and then that Q&A session at the end. So starting off with how to find answers and ask for help, we have public documentation available at circleci.com/docs. It's a great place to explore different concepts on CircleCI. You can find almost any information you need on the docs. If something's not clear, please reach out to support, let us know. You can go to the Support Center. We have a great knowledge base where you can search for almost any error message you see. There's a good chance we have an article on it. If you're unable to find your answer in the Support Center, feel free to open a support ticket with the button on the left that says "Can't find your answer." You can submit a support ticket directly from the CircleCI dashboard by dropping down the support button and clicking Get Support. Our community support's available at discuss.circleci.com. Discuss is a great place to reach out to the community and find users who are doing something similar. There's something specific about a third-party tool, library, or dependency that you're using and having an issue with, there's a good chance that someone on Discuss has experienced that as well. All right, moving into executors. First up, we have Docker. For Docker, CircleCI offers a ton of convenience images, which are language specific. Some examples are Ruby, Node, PHP, and Android. There's several different resource class options. Here are the top 5 that cover most use cases: small, medium, medium plus, large, and extra large. If you need more resources than 8 CPU and 16 gigabytes, it's certainly possible. Feel free to reach out to support and we'll be happy to help you out. To configure Docker, you can see the configuration example on the right side. We identified the version of CircleCI that we're using, which is 2.1. We have the jobs, build, Docker, and specify the CircleCI node Docker image. And the steps, we check out the code, and then we run echo Docker. For Windows support, it's a VM-based machine to guarantee full job isolation. The Windows executor uses server core version Windows Server 2019 Data Center Edition. PowerShell is the default shell, but Bash and CMD can be manually selected. Docker Engine Enterprise is available for running Windows Docker containers. Currently, we only have one resource class for Windows, which is Medium, which provides 4 CPUs and 15 gigabytes of RAM. A configuration example for Windows, we specify the version key to version 2.1. We're using an orb to make it easy to configure Windows. This is the CircleCI Windows orb, version 1.0.0. In the jobs key, we have the build job with a Windows VS 2019 executor. We check out the code and use PowerShell to echo Windows. More information on the Windows executors is available at circle.ci/hello Windows. Next up, we have the machine executor. The machine executor is a Linux Ubuntu operating system. It gives your application full access to operating system resources. It allows you to spin up privileged Docker containers. For the machine executor, we have 2 resource classes available to use, medium and large. The medium gives you 2 CPUs and 7.5 gigabytes of RAM. The large gives you 4 CPUs and 15 gigabytes of RAM. One caveat to using machine is the spin up time. In Docker, we typically see the spin up happen in a few seconds. The machine executor, we have expectations that it could take anywhere from 30 to 60 seconds before your job will start executing the job steps. An example for configuring the machine executor, we specify the version key to 2.1. We specify a job called build, which uses machine true. And then we check out the code and echo machine using bash. The macOS executor is available for users who need to perform testing for iOS and macOS applications. The macOS executor provides access to iPhone, iPad, Apple Watch, and Apple TV simulators. We have 2 resource classes available for macOS. However, if you need access to the large resource class, you need to reach out to support and we can help you get started. The configuration example on the right will spin up a macOS executor with Xcode version 11.0.0. We'll check out the code from the repository and echo macOS using bash. For more information on the macOS executor, visit CircleCI/hello Mac. Some best practices when using the different executors. Use as specific tag or image ID as you can possibly use. Using CircleCI/node will use the most up-to-date release of the Node.js Docker image. If you become more specific, then you can target a specific version of Node that you're using in your development environment, such as Node 9.10.1 or Ruby 2.4.2. If you happen to run into any kind of race condition where you're using a database and the application will begin running before the database has had a chance to fully spin up, you can use Dockerize to wait for the database to be available before continuing. That's done using Dockerize-wait. And then use 127.0.0.1 and then the application port. And then it's good to set a timeout to ensure that it doesn't wait too long. We support most container registries. An example of that is the AWS container registry and Quay.io. You can authorize with those 2 registries, just as the example on the screen. The AWS, you'd use AWS_auth, provide your access key ID and your secret access key. And with Quay.io, you would provide a username and password to access those containers. Moving on to workflows. Why use workflows? Workflows allow you to decompose your build settings, create a story of the tests you run on CircleCI with frequent end-to-end tests, run and troubleshoot jobs independently with real-time status feedback, schedule workflows for jobs that should only be run periodically, fan out to run multiple jobs in parallel for efficient version testing, and fan in to quickly deploy to multiple platforms. Some definitions with workflows. Workflows is a set of rules defining how jobs such as build, test, and deploy are run, giving teams granular control over their software development process. A job is a collection of steps and an execution environment to run them in. A step is an executable command. A build is an obsolete way to describe jobs and workflows altogether. And then an example of that fan out, fan in workflow is the image on the screen. The types of workflows, we have scheduling and cron, which allows you to define a schedule for jobs that should only run periodically. Approval jobs, which provides a control over steps that need to be manually approved to continue, such as a deployment step. Branch specific allows you to specify which branches a build should run on, and tag specific, which allows you to specify which tags a build should run on. Moving into secrets management. We can use a couple of different methods to modify secret management. The first one's environment variable. You can set the environment variable can be set at several different steps at the step, job, and container level. These are all defined in the config.yml. At the step level, you would identify using the environment tag and then the name of the environment variable you would like to set. At the job level, it would go under the job name of environment and then the name of the variable and value you would like to set. And then the container level, you would specify it underneath the image which you're using to run the build on. Defining environment variable from the project settings. This keeps the environment variable in the UI and on the CircleCI backend rather than stored in your config.yml. Defining environment variable from the project settings is easy. Click add variable. It'll prompt you for the name and value of the environment variable, and then you'll be able to use that from any jobs within the project. Some gotchas for environment variables. CircleCI doesn't support environment variable interpolation. The following configuration, environment hello, and then greet hello world, referencing the previous environment variable, will not result in the expected outcome. If you attempt to modify the path in the environment variable, there is a possibility that it will wipe the prior set path. So any tools that are installed might not be available, such as node or the uptime command in this example. The solution to modify your path is to use bash environment. In the example, we export path for the Go execution environment to the bash environment, and then it'll be loaded in the shell. Some common problems with environment variables. Environment variables are overwritten. Check precedence order. There's a good chance that if you have an environment variable specified in your config.yml, it's being overwritten. The environment variable might also be set in the project settings or in context. Contexts are also a great way to use environment variables. It allows you to specify in your config to use which context, and context also allows you to restrict access to the context by team. If you need more information on context, you can access it at circleci.com/docs/2.0/context. Moving into test results. CircleCI supports JUnit XML metadata and Cucumber JSON. If test results are not in these two formats, then Insights will not work with them. Here's an example of RSpec, where we output to an RSpec XML. We store the test results to get the data into Insights, and then we can view actionable data on Insights, such as the last build time, the median build time, which jobs fail the most and which jobs are running the slowest. Moving into build optimizations. It's a bunch of different caching strategies we use to optimize builds. You can use dependency caching, workspaces, artifacts, and Docker layer caching. Dependency caching is most commonly used to cache application dependencies between job runs. Workspaces are used for data produced in a job that needs to be available to subsequent jobs in the workflow. Artifacts are for data that is available after a job finishes. And Docker layer caching is used when building custom Docker images on CircleCI. Dependency caching will persist data between the same job and multiple workflow runs. It's the most used caching strategy. This is useful in instances where if you're using Node.js, you would cache any dependencies that you commonly use. That way it can be restored rather than downloaded each time you run your job. An example of dependency caching, here we restore the cache Rails demo bundle v2 And we use a checksum of the gemfile.lock. This way, anytime the gemfile.lock is updated, it will automatically use a new cache. The secondary cache key is more vague. This means if we're unable to find the specific checksum associated with this gemfile.lock, we'll take the most recent version of that same cache. Following the restore cache, we run bundle install. This will install any packages that aren't already available in the machine, which if caching was able to find a valid cache, most of those dependencies should already be available, and bundle install will take no time at all. At the end, we save the cache just in case bundle install had to install new dependencies, or there were some changes to some already existing dependencies. We save that cache so it can be used in subsequent job runs. The cache key is a unique identifier. Some common templates to the cache key we use is .branch, .build number, .environment variable, variable name, checksum, file name. So the branch, just as described, will create a cache key based on the branch that the build is running from. The build number, same thing. It'll grab the CircleCI build number and use that to create a cache identifier. Environment.variable name, if you'd like to create a cache based on any environment variable you use, that's a good one for that. And then checksum file name creates a unique checksum for a file. Any dependency, it's typically used in any dependency definition file, such as a package.lock or a gemfile.lock. Rule of thumb on dependency caching is start from being specific and become less specific. The more specific you are, the better chance you're going to have of a valid cache hit that is actually useful. The less specific you are, there's a chance that you might hit an old cache that could break your project. There is no way to clear cache. A possible workaround is to use a version key within the cache. In this example, my cache v1 branch and then checksum pom.xml. If this cache happens to become corrupt and I need to use a brand new one, the key is to the idea is to increment the version key to start using a brand new cache that will not be corrupt. Moving into workspaces, workspaces move data in between sequential jobs in a workflow. An example of using workspaces, here we make a directory for workspace. We echo hello world into a file, into echo output. We persist to workspace and save the echo output. Downstream, we will attach the workspace. And then from that point at the downstream job, you'll be able to access the workspace /echo output file. Artifacts are used to persist data after a workflow is completed and gone. This can be used in instances of like application distribution, although we don't guarantee how long an artifact's going to be available, so it's not good for long-term package distribution. An example of creating artifacts, we call it creating dummy artifacts. The command to create a file, this is my artifact files in a directory, and we store the artifacts from tmp artifacts. Last but not least, Docker layer caching. DLC caches the individual layers of any Docker images built during your CircleCI jobs, and then reuses unchanged image layers on subsequent CircleCI runs. Rather than rebuilding the entire image every time, in short, the less your Docker files change from commit to commit, the faster your image building steps will run. DLC can be used with setup remote Docker, can be used on the machine executor, and can only be used when building images on CircleCI. Moving into parallelism. Specify parallelism, use the parallelism key and the job identifier. This will spin up the same container as many times as you specify for parallelism to run the same steps or to use for test splitting. When splitting tests on CircleCI, it's best to use the CircleCI CLI to split tests and glob them. In this example, you can glob the tests in the spec folder, all the Ruby tests, and inside the build, you can glob the tests and then split the tests to use during parallelism. Debugging failed builds. Common errors and mistakes on CircleCI. Exit code 137 means that you are out of memory. If you're using a Java-based image or building Android apps, there's a good chance that the Docker container doesn't have enough memory. So the solution to this is raised to a higher resource class to provide more resources when the application's building. Some optimizations you could try is by setting the Java options, or take a look at our support center. We have a lot of good information on out-of-memory errors. Filtered tag in a workflow, but every commit is running a build. When you filter only on tag, it will attempt to filter on branch first. Since there's no restrictions on branch, it will still run the build every time. The solution here is to set ignore branch in the filter to ignore all branches, or specific branches that you would like to ignore. Problem, push a commit, but there isn't anything happening in CircleCI. Solution is to check YAML syntax with the CircleCI config validate. There's a couple of different issues that can happen if you push a commit, nothing's happening on CircleCI. The most common is the YAML syntax is invalid. If you run CircleCI config validate and you're still unable to push a commit to CircleCI, please open a support ticket. We'll be happy to investigate that. If you run a command, a common operating system command, and you receive command not found, there's a good chance you're modifying the path environment variable. If the path environment variable is being modified, a lot of the commands will go missing because it overrides the original path environment. Debugging using SSH. For more intense troubleshooting, you can SSH into the build executor while it's running to modify what's going on, or even manually trigger the build from the inside to watch steps as they go along. Moving on to deployment. CircleCI continuous integration is used to test and merge changes into the main branch as often as possible. Continuous delivery is used to deploy those changes so your users and customers can utilize these changes as fast as possible. CircleCI supports many development platforms such as AWS, Azure, GCP, Heroku, and a ton others. The deploy step is the easiest way to start a deployment on CircleCI. And orbs are reusable configuration, which can help make that deployment even easier. You can check out our orbs registry at circleci.com/orbs/registry. The approval step is always one to talk about when we speak of deployments. Approval is a way to control the deployments. Approval jobs can be restricted by user groups by creating a secure context. In the example here, we have a job called build and a job called request testing, which is an approval job and it requires build. So following build running, the job will stop running and wait for an approval. The following job require context will require the context orb global, and this step requires request testing. What will happen if someone authorizes the build who is not a part of the secure context, the build will later fail because they don't have access to the context. CircleCI APIs. You can use APIs to trigger a build at any time, retrieve artifacts, get project and build information, and integrate with other tools. How to use APIs. To get an API token, you'll visit circleci.com/account/API. A note about the two different API key types. The project API token is read-only. It can't be used to trigger builds. The user API token will grant read-write access and can be used to trigger builds. All right, we've reached the end of the office hours presentation. I'm available for questions. Feel free to put those in the chat or the Q&A section in Zoom. Can we use workflow cache for Docker images? When building Docker images, workflow cache won't work. To use cache when building Docker images, you would need to use the DLC Docker layer caching feature. In a fan-out, fan-in case, how could I have my Docker images build in parallel but come together for our test phase? So this can be controlled using the requires tagged. I have an example here. So the requires tag can be used to modify how the workflow runs. If there's no requirement on a job, the workflow orchestrator will say, I'm going to run all these jobs at the same time. If there's a requires tag, then for the test phase, for example, let's say you run build and request testing. Build can run in as many parallel instances as you would like by specifying it further. And then the requires build, request testing will not run until build has completed. So if you set requires on the Docker build images, then the testing phase won't start until all of them have completed. You mentioned that orbs are mostly the default way to deploy. What are the benefits of running orbs against normal API CLI tools? Deployment in terms of build time and ease of maintenance. So orbs make it easy to deploy because, so orbs are just the YAML config that you would put in your config.yml. It creates a reusable configuration that you can use like a library. So we have a ton of tools such as the, oh, by the way, the orbs all use the API and CLI tools that you would normally use for deployment. An orb is really there to create a reusable library that makes it easier to interact with those tools and ensure that the tools are already installed. All right, I'll give it a few more minutes in case anyone's typing any questions. Have situations improved for mono repo support? i.e., can we conditionally run selective build steps? We don't officially support mono repos right now. However, if you check out the orb registry, I believe there is a community orb that was developed to ease the use of mono repos. there a way to make insights work with just testing framework? I am not familiar with the just testing framework. Insights only works with valid cucumber JSON and, sorry, let me pull it up just for reference. So test results in Insights can only be displayed with valid JUnit XML metadata and Cucumber JSON. If the output of just testing framework is not either of those, then it likely will not work with Insights. If you open a support ticket, support@circleci.com, we'd be happy to help you look into that. All right, looks like we are out of questions. I'm gonna go ahead and call it here. I appreciate everyone joining today and for the great questions. If any of your questions weren't answered, we'll reach out to you at the email address you used to sign up for the webinar. If you have any additional questions that I wasn't able to answer during the webinar, please feel free to reach out at support@circleci.com. Thanks, everyone.